Now we will look into our third learning outcome, which is on integration by parts. Integration by parts is a very important method in integration. So this method is derived from product rule. So for examples, if you need to integrate two functions that are product of each other, then you need to apply integration by parts. So let's examine how to actually use this product rule to derive integration by parts formula. So example, this is product rule. I think you're very familiar when you need to differentiate dy dx. So this is your y, fx times gx, product of two different functions. So it will be differentiate the first function f prime x, copy the second, plus differentiate the second function, copy the first. So this is product rule. So when you integrate both sides of this equation, you will actually arrive on the method of integration by parts. So when you integrate dy dx, you will actually get fx gx. Okay, when you integrate dy dx, so when you integrate dy dx, you actually get that y. So the y is fx gx. So integrating this part gives you the y, which is the fx gx. Okay, and then you add an integration sign to both of these because you don't know the function, so you can't really integrate them. Okay, and if we need to integrate a function which is product of each other, so for example, if we need to integrate this part, so we can make this part as the subject of this equation. So we rearrange, we move this to the left, so this came here. Okay, and we have actually moved we have actually changed the sign of fx dx minus g prime x fx dx. So we just rearranged it. Okay, so fx dx minus integration of g prime x fx dx equals to f prime x integration of f prime x gx dx. So we just rearranged it. We may have made this as the subject of the equation. So this is the formula which is used to do integration by parts. So what you need to do, you need to identify a function that needs to be integrated, and the function has to be product of two different functions. You have to assume that one of the function is f prime x and another one is gx, and substitute accordingly over here. So now we will look at an example on how to apply this rule to solve questions that require integration by parts methods in the coming slides. Now we will look at the first example for integration by parts. So as you can see, we need to integrate x multiplied by cos x, which is a product of two different functions. Therefore, equating it to the formula which we derived from product rule in the previous slide, integration of f prime x gx with respect to x equals to fx gx integrate minus the integration of g prime x fx with respect to x. So by equating our question to the formula on the left hand side, so we need to identify which is our f prime x and which is our gx. So in order to identify that, the goal is actually to make the integration simpler. Therefore, definitely we will take gx as x, simply because when we differentiate gx, we will actually get one which will actually simplify the functions later on when we substitute it into the right hand side of the equation. So if we chose gx as x, then definitely cos x will be the f prime x, and we need to integrate f prime x in order to identify fx. So integrating cosine x gives you sin x. So once we identify our fx, f prime, gx, and g prime x from the question, then we need to move on to substitute it into our right hand side of the equation. So in this case, integration of x cos x, which is the left hand side, which is the question. So the right hand side, we substitute the fx, which is the sin x, multiplied by gx, which is x. So this is gx times sin x, okay, minus integration of g prime, which is 1, and substitute fx, which is sin x, accordingly. And don't forget to write dx with respect to x. And next, we need to solve this in order to arrive to the final answer. We will look at the next example, which actually shows integration of a function which is a product of two different functions, which is 3x plus 2 and e to the power of x dx. So our first task here will be to identify our f prime x and also gx based on this function. So for between 3x plus 2 and e to the power of x, obviously we will take gx as 3x plus 2, because we can, when we differentiate gx, we will actually reduce the function to 3, which will then make the right hand side of the equation simpler after substitution. And if we took gx as 3x plus 2, then definitely f prime x will be e to the power of x, and integrating f prime x, which is e to the power of x, will actually give you e to the power of x again. So after we identify our f prime x, gx, and then identify our g prime x and fx accordingly, our next step would be to substitute these four functions obtained on the right hand side of the equation. That would be simplifying the right hand side to substituting fx as ex, your gx is 3x plus 2, minus integration of g prime x is 3. So you can write the 3 in front of the integral, and copy the fx, which is e power x, accordingly, and don't forget the dx. So once you substitute, your next task will be solving each of it individually. So the first part here you just copy down, and the second part here you integrate. So when you integrate e to the power of x, you actually get e to the power of x plus c. So don't forget to factor in the 3 and also write down the c, because this is an indefinite integral. And next part, you can actually simplify e power x as the common factor. And once you simplify, you will arrive to the final answer, which is e power x multiplied by 3x minus 1 plus c. Now we will look into a more complex example involving integration by parts. At times, you need to repeat the process of integration by parts more than once in order to solve an integral. So for example, if you have a question that requires you to integrate a function that has x squared multiplied by sine x with respect to x, you might need to apply the integration by parts twice in order to solve this function. So for example, if you need to integrate x squared sine x with respect to x, so you've got product of two functions. So obviously integration by parts is involved here. So your first task will be, you need to identify your gx and your f prime x. So your gx in this case, it will be a function that when you simplify it, when you differentiate, it will become simpler. So choosing x squared as gx is wise, because differentiating gx will actually give you 2x, which reduces the power of the function. And obviously, if you choose gx as x squared, then f prime has to be sine x. And your next step will be arranging it into the formula. given in the previous slide. So when you arrange it into the formula, you will actually get gx, which is x squared, multiplied by fx, which is negative cos x, which gives you this, and then plus with integration of, sorry, minus with integration of g prime x fx. Yeah, so the negative cos x can turns the minus into plus. Okay, so if you look at this at your first attempt of integration by parts, you will reduce your question to negative x squared cos x plus integration of another function, which is product of two different functions, which is 2x and cos x. So therefore, a second layer of integration by parts is required here. So therefore, you continue. Based on this, obviously, you will choose your gx as 2x, and your cos x will be your f prime x. And then from your f prime x and gx, which you choose from the question, you identify your g prime x, which is 2, and your fx obviously will be sin x. So once you get your fx, gx, f prime, and g prime, you actually substitute it into the formula. So therefore, integrating this part here, this question here is written here again, just for this part, it will become gx fx minus integration of g prime x fx. Okay, and don't forget your dx. So once you reach to this stage, you realize that this part here can be solved easily. So you have actually completed your integration by parts. So don't forget to write the final answer, which will be negative x squared plus cos x. And don't forget to write down this, and plus the answer for this, which is this part here. So you copy this down, 2x sin x, integrating sine gives you negative cos. So negative negative cancels out and become plus 2 cos x. And don't forget your c, because this is an indefinite integral. Right, so your final answer should be rewritten again from the original question, equals to all the layers of integration by parts which you solved along the way. So this will be the final answer for this question. Next, we will look at an example that requires you to evaluate between 0 and 1 product of two functions, which is x squared plus 4x multiplied by cosine x. So for this particular function, you require integration by parts. So first task will be choosing your gx and your f prime x. So your gx obviously has to be your x squared plus 4x, because when you differentiate this quadratic function, it will become a simpler linear function. So therefore, gx is x squared plus 4x, and your f prime x will be cosine x. So gx is x squared plus 4x, g prime is as stated here, 2x plus 4. Your f prime is cosine x, integrating cosine x gives you sine x. So once you get this, you substitute it into the formula for integration by parts. So it will be fx gx sine x multiplied by x squared plus 4x minus integration of g prime x fx. So g prime x is substituted accordingly, and this is fx, and integrated with respect to x. So once you reach at this stage, this part on the left is actually the question. Okay, so you write it in a line in order to see the flow. So it's understood that this part here still has got two different functions as a product and needs to be integrated. So you need to apply integration by parts again, the second layer. Okay, so based on this, obviously gx is again 2x plus 4, because when you differentiate 2x plus 4, you will actually get 2, which will actually simplify the function. And your f prime x now is sine x. So once you identify your g prime x and your fx, so once you get your gx, you get your g prime x, and then your f prime x is sine x, and your fx will be integrating sine x gives you negative cosine x. So the next task will be applying integration by parts to this part. So your this part here is integration by parts here, copied again. Okay, so it's fx gx. So fx is negative cos x and gx is 2x plus 4. So it will result in negative 2x plus 4 cos x minus integration of fx g prime x. So minus minus cancels out the negative, becomes positive 2 cos x dx over here. And then your next part here, you realize that you have actually successfully solved the integration by parts, because this part here can be directly integrated to sine x. So your final task will be writing all the layers together. So you copy the original question, and the original question will be this one. This is the original question, and then you copy down the first layer just now that you got, and the second layer which you got over here. Okay, and then substitute 1 minus substitute 0 accordingly. So you put in the values for your calculation. So your final answer is 3 sine 1 plus 6 cos 1 minus 4. Okay, now we will look at the third example. It requires you to evaluate e to the power of x sine x. So this again is a product of two different functions. Therefore, integration by parts is required. Okay. So in this case, definitely we will try to take a function which is easy to be differentiated. So we chose the gx as sine x, and f prime x obviously is e to the power of x. Okay, and when we differentiate gx, you get cos x, and you need to find fx, so you integrate f prime x, gives you e to the power of x as well. Okay, so once you have it, you substitute it into the formula for integration by parts, which is this. You copy the question again, and this part here is fx gx minus integration of g prime x fx. So g prime is cos x, fx is e to the power of x. Okay, and then the next part, if you realize, this part here is actually requires a second layer of integration by parts again. So in this case, we have to identify again our gx is cosine x. Okay, so g prime will be negative sine x, and f prime is ex, and again fx will be integration of e to the power of x, which will give you e to the power of x. So once you identify these four functions, for this part here, again you apply integration by parts. So write it into the formula form, which is integration of ex cos x dx, which is this part here, wrote down here. Okay, fx gx is written here, minus integration of g prime x, which is negative, negative, it cancels out the negative, becomes plus sine x, and then copy fx. So it's fx g prime x dx. If you realize, this part here requires integration by parts again. So when you normally when you already do two layers of integration by parts, you need to look at the question as a whole. Okay, so if you go back to the original question, you need to copy back the original question, which is e to the power of x sine x dx. So you copy the first layer of integration, which gave you this. Okay, And then the second layer is this part here, which you just did just now, integration of ex cos x. Which you got this part here is this part here. Okay, copy it down. This is the first layer. This is the second layer. So completed all together. And you have to look at the question as a whole. What I mean is, if you look at this term, this is actually the original question again, if you pay attention. Okay, so what we can do here is we can instead of doing another layer of integration by parts, we can actually rearrange this part here. So minus third of this, you can actually move it to the left hand side. So it becomes 2 of this. So it's like as if 1 plus another 1. When you move it, this becomes plus, right? So the terms are the similar, so it becomes 2 multiplied by integration of ex sin x dx, and then this right hand side remains over here. So if you realize, the original question was just integration of sin x dx, so this 2 here, you can bring it over to the right in order to get the answer. Okay. Now this part here, please don't forget to add the c. Okay. So don't forget to add the c, yeah. Plus c over here. Okay, this is very crucial. Just remember to add plus c because this is indefinite integral. Now we will look into some special cases of integration by part. It involves a dummy function. Dummy function means the function don't exist, but you create another function. Okay, so we'll discuss some examples. Normally, functions that have ln x, sine negative 1x, and cosine negative 1 and inverse tangent don't have standard integrals because they can only be differentiated. All these 4 functions, if you pay attention, inverse sine, inverse cos, inverse tangent, and ln x, they can only be differentiated. They can't be integrated. So in order to integrate them, you need to introduce a dummy function which is known as 1. So introduce a number 1, and you will actually choose that as f prime x, so that you can actually find fx by integrating 1, which gives you x. And you can proceed with the integration by parts. So in the coming slide, we will look at some example that uses dummy function in order to perform integration by parts. So the first example that uses a dummy function is, for example, if you have to integrate ln x, you can't integrate ln x. There is no formula. You can only differentiate it. So therefore, you introduce a dummy function, which is 1. So 1, it'll be 1 multiplied by ln x. Because you can only differentiate ln x, then obviously gx is your ln x. So g prime x will be 1 over x by differentiating ln x. And your f prime is definitely 1, because 1, when you integrate it, it becomes x. Then you proceed with the standard formula for integration by parts. So it will be fx gx, so x ln x, minus integration of fx g prime x. Fx g prime x, you copy it accordingly, simplify it, okay, and then you integrate this, and you will arrive to the final answer. And don't forget to add the c because this is an indefinite integral. Okay, now we will look at the next example, which is integration of sine negative 1x dx. So when we look at this function, we can't directly integrate sine negative 1x, so we have to create another function as a dummy function. So we use 1 as a dummy function. So it's 1 multiplied by sine negative 1x. So we will take gx obviously as sine negative 1x because you can only differentiate sine negative 1x. So it will give you your g prime is 1 over third of 1 minus x squared. This is related to last week's lecture. Okay, and then your fx definitely, f prime x is definitely 1. So fx, when you integrate 1, will give you x. Okay, so next step will be arranging it in the formula form. It will be fx gx, fx gx. Okay, this is fx gx minus integration of g prime x multiplied by f prime x. Sorry, g prime x multiplied by x. Okay, so you arrive to this. So when you look at this part here, it doesn't require another layer of integration by parts, but you can solve it using the substitution method. So you can take u as 1 minus x squared. So recall back, you have learned substitution in semester 2. Okay, so to integrate this part, I've used the term t here. Okay, it's similar to using u. So say example, I use t as the content of the bracket 1 minus x squared, then dt dx is definitely negative 2x. Okay, arrange it in such a way so they can substitute it directly. So x dx here becomes dt over negative dt over 2. So you can directly substitute negative dt over 2, and the denominator becomes third t. Yeah. So we proceed by integration by substitution for this part. So here you reduce it to negative 1 over 2 third t. Okay. And next you need to do a direct integration. So t power to the power of negative half. Negative half is brought outside. This third t becomes t to the power of negative half. And now you integrate. Negative half is maintained as a coefficient. Okay, and this is a normal integration. So negative half plus 1 is half divided by half. So it becomes, when you divide by half, it becomes multiplied by 2. Yeah, plus c. So your last task will be writing all the layers together. So your final answer here will be, in terms of copy down the first line just now, x multiplied by sine inverse x plus with the final answer of the substitution, where you substitute the t in terms of x again. Okay, so final answer is third of 1 minus x squared plus with c. So even though substitution is a semester 2 knowledge, sometimes while doing integration by parts, you need to still apply integration by substitution to arrive to your final answer. So please recall back how to do integration by substitution.